Okay, so let's look at a problem number 3. This problem is asking us to determine I/O, and I/O is right there. And it's saying we know that I1 is equal to 1 amp, so that at the very end. So we've got a lot going on here. We have a lot of resistors, and we have a bunch of currents, okay? And this looks like quite a lot, but the thing is that if we look at this, the circuit is more complex than it actually looks, okay? And what do we mean by that? So we have I/O as a source, but if we notice I/O and I5 are the same current, okay? So if I was to look at that current I5 that's headed this way, we see it's going to travel down and keep breaking off like this, and to where it'll eventually end back up as I5. Okay. So what do we know about this though? Well, to find I/O, let's remember that I/O is also going to be an I source because it's the source coming from right there. But what we can say is that we see that all of these resistors here are in parallel, which that can be useful for us. If we know a bunch of information about currents, and we see that everything is in parallel, we can use the current division. Okay, and we write that equation out. We can say I of a number is equal to our equivalent over our number times I of source. Okay, well, let's look at what we have here. We know that I1 is 1 amp, and we also know that it has 16 ohms on that resistance branch. So, and we know that all these are in parallel. So if we were to go and find the R parallel, then we would know our equivalent, the R number, our that current down that branch, and then the only thing we don't know is the source, and we can just back that out. So let's give that a shot. Let's see what it looks like. So R parallel here is going to be kind of long, so we're going to do 1 over 16 plus 1 over 8 plus 1 over 4 plus 1 over 2. Give us a little bit more room. 1 over, apologies, that's 1. Okay. And I'm going to pause real quick and type in my calculator, and I'll be right back with the value. Okay, so our value is going to be 0.516 ohms, okay, for R parallel, which is equal to the R equivalent in our case. All right, so what we can do now is we can just go plug in our values. So if we did I1 is equal to R parallel over R1 times I of O, therefore we can say 1 amp is equal to 0.516 ohms, 16 ohms on that branch there, times I of O. And therefore, if we go and rearrange, we'll find that it is 31 amps. Okay, so all we're doing here is using the current division equation and working backwards. And this is a question I've seen in the past, and it's a very good test of your knowledge.